Welcome to CS 547. Next week will be Dave Rummelhart, who's from the psychology department here at Stanford and has been doing work on using neural nets for cursive handwriting recognition. We'll be talking about that. Also, I have now sent out in the last announcement, the one that went out for today, if you got it, the bottom of it has, I think, the next 4 speakers listed. I'm gradually getting the definite answers for the rest of the quarter. So I will probably, hopefully by the next week, be able to send out a notice that has the whole list. I guess that's all the administrative stuff. Why don't we move right along? Today's speaker is Andy Hertzfeldt, who I guess you could call a Silicon Valley legend. He's been involved in this business since the beginning and was one of the small but hearty band who set out to take the ideas of the graphic user interface and package them in a box that the rest of us could afford. He was in the original development team for the Macintosh and did substantial parts of the programming in that. He was a founding, were you a founder of Radius or
one of the founding shareholder? I had the 3rd stock certificate, but I was never an employee.
But you did consulting at Radius.
For the first year and a half.
And all the software for Radius for the first year and a half. He worked for Frox, a company that was doing a home entertainment system, and actually, those of you who were here two years ago, I believe it was, Andy gave a talk on the work he had done there. And then he went off with a small but hearty band to form a company called General Magic. I guess I could say to do for the small handheld mobile computer of the 90s what the Macintosh band did for the desktop of the 80s. That is to look into the basic questions of how should we interact with something of that general kind, how does it tie into the networks and the rest of the world. And those of you who follow the computer trade press at all know that they finally announced at MacWorld this year. Andy tells me this is only the second public presentation about this work, the first having been the one at MacWorld. And there are 2 components to what they're doing. One is the underlying operating system and communication system, which is called Telescript. The other is the interface, which is called MagicCap. And Andy will be describing those for us today.
Okay. So I'd love to demo the software, and we'll spend most of the time doing that. But I just wanted to talk for a few minutes at the beginning about why we founded General Magic, what is the mission of General Magic, and most simply put, the idea that we originally had that made it worth it to come together and form a new company was to redefine telephony. We had all experienced electronic mail as sort of computer nerds, and yeah, okay. Okay, I'm sorry. Yeah, okay. Is we had all experienced electronic mail and seen how it had transformed our lives, but we also saw the awful complexities involved with using electronic mail on personal computer platforms. And so we basically had this idea is if we can make electronic mail as ubiquitous as the telephone, as a graceful alternative to telephony. Everyone here is a telephone user. It's hard in this day and age to live without a telephone. Yet the telephone has problems of being sort of real-time and jarring. It requires your full attention to participate in a phone call. So we had this idea of what if it just as easy as making a phone call, you can write in a little electronic postcard and have it drop into the person's pocket as they're traveling around. That seemed really compelling. And so to pursue this mission of redefining telephony, after some investigation, we realized we not only needed a new kind of telephone device, which was the handheld device that Terry was referring to, but we also needed to create a new kind of telephone service because part of the problem, the software that people interact with, is not just in the device, but out in the network. And we were lucky enough to run across a brilliant communications architect, Jim White, who has had a long and storied career. He's considered to be the inventor of the RPC, the remote procedure call paradigm, when he was at SRI, and is also the principal person behind the X400 mail standard. And he had, through his long experience in dealing with why communicating applications are so hard to create, came up with a breakthrough technology called Telescript. And I'll be talking some about that. But the main thing I want to do is demonstrate MagicCap, the user interface. And so if we can get the thing on the screen, I assume, yeah, okay. The first thing to talk about, this is let me say that this is running on a Macintosh, and we're making MagiCap available as an shrink-wrapped application on Windows machines and Macs. But our heart, the reason we designed it was not to run on desktop computers, but to run on small handheld devices. And it's just hard to demonstrate those, so I think we're stuck with the Mac today. It's also hard in a room like this to demonstrate the communications features, which are really at the very center of it. So I'll just kind of gloss over the real communication. I'll show you how sending works, but I'll send to myself here because I didn't want to have to get a modem line here, etc. But so anyway, as I said, we're going, and the other thing about this is please ask questions and challenge me. It would be great if I can learn something from this, and I'd love to see, especially pointing out weaknesses in what you think we're doing is the thing I'd like to hear the most. But so anyway, directing your attention to the screen here, one of the major goals of MagiCap was to break through the complexity barrier, limiting ordinary people from using digital technology. We want to go after the telephone user, the television user. It's our job as user interface designers to have a person walk up to this thing and be able to start using it with no prior instruction. That was our initial goal. No manuals. You have to be able to walk up and get a satisfactory experience. Many devices, the first experience of the user, either in a store or someone demonstrating, is very frustrating. And so how do you do that? How do you make something that the user already knows how to use before they've ever experienced it? Well, we didn't know. We didn't know the answer to that question, and the process of developing MagiCap, it was really a process of discovery. But things began to come together for us when we realized that if we used a real-world metaphor, if we can make the world on the other side of the screen as congruent as possible with the world on the user side of the screen, people can use the intuition and experience that they've been building up all their lives in operating the software. And so that's sort of the key to getting someone who's never seen it before to be able to use it. The basic way of interacting with the device is just touching on it with your finger, and that introduced a level of user interface challenges that I hadn't experienced before. On a mouse, usually maybe a 4x4 square pixel area is okay for hitting objects, although maybe it has to go to 16 by 16 for certain types of things, but you really can point to an individual pixel. With your fingers, it's more like 48 pixels is about as close as things can be. So that's an interesting design choice. You can use a stylus to write on it too, and a stylus is just a toothpick will work just fine. We use resistive screen technology, so there's nothing active in the stylus, and that's principally good for writing, for spreading out digital ink. But you also, and some users prefer to use the stylus to tap on it. But anyway, the basic way the navigation metaphor works, that this kind of virtual world inside the device, is you touch on an object, usually with your finger. I'll use the mouse here. I'll tap on the file cabinet, and you'll see that it expands to fill the screen as if kind of the user's eye is the zoom lens, and by tapping on an object, it focuses their attention on it, so you can see an expanded view. In this case, I tapped on the icon for the file cabinet, and up comes a realistic looking file cabinet. One of the things we have to do is engage the user by creating this tangible reality. And so the more real we can make it seem to them, the easier time they have with it. We want MagiCap to be very explorable. As I say, no prior instruction is necessary. So at the upper left-hand corner of the screen always is the name of the place you're at, to give you a concept about where you are. If you tap there, most places have some instruction about how to use it. In the upper right-hand corner of the screen is a place you can tap on to step back to get the bigger picture, to have the zoom lens retract back out. So in the case of the desk here, I'll step back out. It's usually the place you just came from. We're at the bigger picture of the desk here. Let me just go into a few other places here just to give you the feeling for it. Like I'll go into the name cards. I just filled out a stub one for myself. It has to kind of know who the current user is before you can really use it. But then I step back to the bigger picture of the desk, or the phone application, same type of thing, or the clock. But so anyway, as you can see here, the desk real estate is sort of limited. We can comfortably fit 5 or 6 things on it. And we have a little overflow area. This drawer here is a scrollable area, so more things as they can install can live in there. But we also wanted to make MagiCap an extensible platform. Both the founders of the company all came from Apple, where we saw that the magic of the personal computer industry was not just in the systems companies. It's in the people like you, the third parties, who take the basic systems and take them places where the designers never imagined them to be. So the metaphor itself has to be open-ended and extensible. So for that reason, there's not just this one place in MagicApp. Another thing I should mention, by organizing the functionality like rooms in a house, is there's one good thing about that is users are used to rooms as a context for an activity. You have different set of expectations of what you might do in your kitchen versus your living room versus your garage, etc. The other thing it does is people are great at perceiving gestalt. So a screen that has more than a dozen touchable elements is not perceived. You don't perceive the complexity of the dozen touchable elements when you see a sort of framing picture. You say, oh, this is a room. It's not 12 separate things, which in fact both are true. But so anyway, because the metaphor itself has to be extensible, there has to be more rooms that developers can create and also other rooms built into MagicApp. So for that reason, you can step back to a bigger picture than this desk here. Oops, I keep knocking this. I should put it on my belt. We call this the hallway. And in the hallway, there's doors. I can tap on a door, and we go back into the desk scene here. But we can look at some of the other doors in MagicApp. Like this is a room called the library, where again we use metaphors where we ever can to make it tangible and vivid to the user. So if I tap on a book here, there's 5 or 6 books about MagicApp built into the system. We use animation wherever possible, and you'll see more of that later. Again, to show the user what's going on wherever we can. You can page through these books. There's even a neat little bookmark feature. I'll just drop a bookmark here, and then I can pull that off, put it in my handy little carrying case, and from wherever I am in the software, if I ever tap on that little bookmark, we'll go back to that particular page of the book. I want to concentrate on the navigation here, though. You can go down the hallway, kind of one screenful at a time, or you can kind of meander by pulling on the corridor here. One of the first things you notice is it's not all just doorways. The reason for that is we always have sort of the secret agenda of delighting the user, of making them smile. But the practical reason for putting in these what might be considered to be superfluous objects are that they create memorable detail. Our testing showed us that if you just have door after door after door, the doors don't do so much for you. They look too much the same. You don't have a sense of place. You might recall, like the last time you were in a hotel and you had to pick out your hotel door from a whole corridor of hotel doors. Probably the way you remembered it was the room number's a big help, but probably you remember it's the one near the soda machine or the one near the stairwell. People remember as a gestalt. So we put these objects here to create memorable detail, to make people have a sense of place. Whenever we put such an object into MagicApp, we may as well make it interactive. I like showing off this picture in the hallway because when you tap on it, it can change to a different picture. And in fact, this illustrates another big theme of MagicApp, which is wherever we can, we create frameworks for third-party developers. And in the case of this picture here, it's possible for third parties to create all other kinds of artwork. And we imagine people making sports posters and Pearl Jam posters, etc. For the users here. I want to talk about one other major user interface trick that we use, which is we have one meta key on the device, kind of in the grand tradition of holding down the Option key or the Shift key in Mac Paint. We built in one key on the device that can modify the meaning of touch, and that's how we hide all kinds of expert features. We very carefully construct these expert features such that you don't need to know about them to effectively use the device, but if you do know about them, you can have some shortcuts. I'll demonstrate. I'll hold down the expert key here. When I tap on an arrow, we go to both sides of the hallway without having to go in between. I mentioned it at this point because if you hold the expert key down when you tap on this image gallery thing here, you get a little control panel where I can show the names of it, or even have a little feature where the picture can automatically change every day. I'll go into some of these other rooms here just to show you. I think the storeroom's an interesting one. This is our interface for managing the memory in the device, which is usually one of the areas that is very difficult for users. People get stuck on programs that can be otherwise extremely easy to use can become extremely difficult to use when you're out of space on your hard disk or you're out of space in RAM. And so I'll talk a little bit more about that later. But the point I want to make now is how we're using, again, we're taking the physical metaphor that was employed by the Xerox Star and the Mac Finder here to the next level of tangibility, of making it seem physical and real. What was great about having these icons on the flat plane of the desktop was that it removed abstraction. Instead of thinking of files as just names, people thought the icons were the files themselves. You can just pick them up and directly manipulate them. But still, that's a level of abstraction. It doesn't seem real. It makes it hard to understand the purposes of the icons because they're just little pictures. Here, we do a very similar thing, but we make them look like storage boxes on a shelf to symbolize the usage of memory, which is just more tangible and clearer to people. And I don't want to spend too much time in here, but maybe if we have some time later, I can show you how you can drag things between different memory cards. We essentially use an expandable shelf to represent a container of memory, either the main memory of the device or some memory on a RAM card or accessed through the PC. Yeah?
Are the size of the boxes proportional to the amount of memory?
We thought of that. But they're not, and the reason for that is the dynamic range of memory usage is a lot more than the dynamic range of the screen. So if you maybe could do that to a point to distinguish one element of the range, but I couldn't have an object here it's very easy for me to have in memory an object that's 1,000 times bigger than another object. I don't know how I would show that on the screen with 400 pixels. Excuse me? Oh, yeah, logarithmically might be a way to do it. The other thing is the size of the boxes here, and maybe this is kind of hokey, but it's really determined by the name of the thing here. And users do want to give expressive names. That's important. But we did consider that. I think I even made an attempt at it. All this stuff, by the way, is how do you design a user interface that is truly usable? And there's only one rule of user interface design. Bill Atkinson, one of my partners and another co-founder of General Magic, always says this, and I believe it in my heart and soul, which is the only rule of user interface design is making the user happy. Any other principle that you can get derives from that. And happy is sort of an imprecise word, but it's giving the users a great experience, making them love it. You've succeeded if you can create something that people love to use. And so that's all we really care about. Yeah?
Would it make the users happier to be able to have each one of these views?
Is users student mics?
Use the mic. Yeah, there's new visitors here today. This is being broadcast on the TV network. When you ask questions, the mic does
okay.
go out too.
Would it make the users happier to be able to have each one of these views in a separate window?
I don't think so. According to our testing, is one of the problems with systems like the Mac is what I call windowitis, which is having many overlapping windows on the screen is very complex and difficult for most people. Although certain types of people, there's power there. And I'll show you how we do Windows in Magic App. Let me just bring one up because we're talking about it now. I had dropped something in the satchel there before, this little paper clip. But you can see that we do most of these things along the bottom do bring up windows. And I'll be talking about the stamper a lot more because it's one of the neatest parts of the software. But one of the things you can see we do, one of the innovations we've done with Magic App and Windows is putting on what we call a balloon spout. Almost always the windows emanate from something. They're a view of an expanded view of something else. And so by putting this little triangle to fix in the user's mind why the window is up there and where does it come from really helps minimize this confusion of windows. Another thing you see we'll do, if I bring up another window, you'll see the first one goes away. And there's ways to override that, but most windows don't want to be up there on the screen while other windows are up there because it creates this complicated thing. I feel that myself when I use it. Just too many windows is not good. But certainly we could, if we wanted to, make it so if we could find a simple way. We're biasing this very much on purpose toward the neophyte. Although, as I'll show you, we also build in features for the expert. I don't know if I answered that well enough, but and obviously you have a point of view, which is you'd like to see it in the windows. But anyway, let's navigate a little more through the hallway here. I'd like to go into the game room here, which is just a place for games to collect. And I wanted to point out an important executive decision-making application we built into Magic App because often in life you have very close calls to make, 50-50 calls that you can't decide to go this way or that way. So we built in a little coin you can flip to help you with those difficult decisions. It's random, or as random as computers get. Down along each side of the hallway is our directories, because there is a type of person who does not want to explore, who wants, show me what you got, I want to go right to it. So on each end of the corridor there's a directory, so if I want to go right into the library from there, I can do that without having to navigate. Another aid to navigation for the expert user, and maybe I'll show a few more later, but I wanted to show if you hold that expert key down when you tap on your step back here, instead of stepping back to your immediate container, it gives you a sorted list of all the places you've been in order of most recent. And so if you are an expert and you don't like step-by-step navigation, you can almost usually get to any place in the software in 2 taps. Yeah?
If you step back from this, would you step back to the directory?
No, you step back to the hallway. Physical rooms, and it's kind of a subtle design consideration, but there are some types of objects. MagicApp is built around an embracing object framework. Maybe I'll talk about that a little bit. But you really ask the objects what they want. The rooms, for when you go into a room, it's more important for the room to reflect the physical reality. So no matter how you got to a room, stepping back will go into the hallway. Other types of objects, like the icons, stepping back to them will go to the icon that you got it, because sometimes icons bring 2 to the same place. There's not as much of a sense of place as there is with a room. But it's really up to the designer of the room and the object that took you there to make that call. And we made it the way we thought what was right for the kinds of objects we were designing. But so anyway, along this hallway is all the information that's kept in your device, and we on purpose keep it as simple as you can. It's easy, and by the way, rooms, you can go into rooms that have other hallways inside them. Although we don't have examples of that built into MagicApp, that could be quite a reasonable thing to do. But we keep, notice that the hallway is not really a hallway, it's kind of half a hallway. It's just one view of it. Again, to keep it as simple as we can. It's kind of a magic hallway in the sense that doors can come and go. Maybe I'll show an example of that. I can load a software package. This would be the equivalent of sticking in a RAM card or ROM card on the device. I'll do this one called the living room, and you'll see another door appeared at the end of the hallway. The hallway's elastic, and it will even put in these extraneous objects, more ones, like it knew to put another clock in there, I think, just to do that. And again, that's an extensible framework. There can be software developers who specialize in hallway furnishings or street furnishings, if they like. But yeah, I want to talk, maybe I went there a little prematurely, but along the hallway is everything that's in your device, but since what we're making is fundamentally a communicator, that's not enough for the navigation. The navigation must also be able to address the world of services outside your device. So for that reason, there's another level we can step back to what we call downtown, where instead of a sort of hallway of doors, you have a street of buildings. But essentially, they're really the same thing, or very similar. Tapping on each takes you to a physical seeming room. The difference is it keeps very clear in the user's mind that you're involving communication. Anything out on the street, you're talking with something at least eventually outside of your device. On the hallway, you're essentially manipulating objects inside your device. So this home here is your home in this electronic community. Tapping there gets you back into your main device. But there are other buildings. Just like with the hallway, there's a directory on each side. This ATT building is the only building that's built into everyone's device, which and the reason for that is it's the user interface for our telescripted service that we're doing in collaboration with ATT. The MCI building can come into your device just by them soliciting you. And I can show how new buildings get in, but because of our relationship with AT&T, we built that one into the ROM. Yeah, it's a whole separate lecture to talk about the personalities of these different companies that we work with. General Magic, when we first started out, we had had Apple as the only company we were working with, but quickly we got Sony and Motorola, and Mark Perret, our CEO, who orchestrates those relationships, used to talk about Goldilocks and the Three Bears. He was Goldilocks, kind of traipsing around the Three Bears, and then we're up to 6 big companies who are, and General Magic is a very unique and interesting business situation because our investors and our customers are one and the same. And that creates for certain tension and dynamics. But the alternative of pursuing venture capital is the way we did it, I think, is much better. General Magic has never taken a cent of venture capital because those people are much more focused on financial results, short-term results. So these big companies are in it with us for the long run. But so anyway, just to show, like the post office here has an extensible set of forms. Oh, I have it set up where I'm calling from, so I'll just use a little option feature we use for development where they kind of fake it. I'm also not registered for the service here, so I'll say, oh, it won't even let me fake that. Okay. I just won't bother here. There's a bookshelf for new directory type things to appear, some statistics. The most important thing here in this post office, and this is something I'll be getting back to in a little bit, are a series of rules for programming your electronic mailbox out in the sky or in the cloud, out in the network. And I'll be talking more about that when we talk about Telescript and what it does for us. But the rules are, and I'll talk more about the rules later. I want to concentrate on the navigation here. So going down the street, there are other buildings. Each one is really a customized front end for a telescripted service out in the network. This one here is an example of what a news agency might look like, where you can express an interest in certain topics and get a custom newspaper back each day or each week with articles that match your interest criteria. You'll notice many of the buildings have a bulletin board, which is our way of highlighting late-breaking news that can change every time you connect with the network. We could get more into these, but I don't have time to go into depth, and unless someone wants to see a particular thing. This is just an example of a travel agency. And I think I'd like to talk a little bit about sort of the vision behind this street. In other words, well, not just what it is today, but how we see it evolving. Initially, and it's certainly true today, the denizens of the proprietors of the buildings on the street will be the large companies with already engaged in electronic communication. They're the ones who have the expertise, and they're the ones who have a drive to be first. Eventually, let me just finish the thought, and I'll get you in a second. But eventually, the people we feel we're really working for are the small-time people, such as proprietors of small stores, restaurants, doctors' offices, public buildings such as your child's school or your congressperson's office can all maintain electronic presences on Main Street. What it will on our downtown. We used to call it Main Street, and someone bought the word Main Street, so we're not allowed to call it Main Street. We call it downtown now. But what it will take to get these small-time people, the restaurants that you go to on a daily basis on the street, is A, selling enough devices so there's some demand for it, and all these services can work without Magic App. They just need the capability to send out a Telescript agent, which doesn't even require a full Telescript interpreter. We have a thing we call Launcher, which is just kind of a way of launching an agent into the network without having an agent be able to execute in your device. But if you if you just buy into that much infrastructure, you can be a customer of these electronic shops. Another point I want to make about the street, and I'll get to your question in a second, is, and this is something people always ask, is that we're not trying to do a sort of snow crash metaverse type thing where everyone has a shared reality on their machine. Each user street will be different in Magic App. These are the services that you're pursuing a relationship with. It takes usually between 10K and 100K worth of memory to keep around all the objects for the user interface. You're not going to want every single possible service there. So each customer street will be different. Just as maybe not from here, but from my house, there's 100 stores I can walk to. I've only ever gone into a very small percentage of them, and the same is true with these services. Although again, not initially, everyone will have all the stores because there'll be so few of them. The first few months, the first year or so. Eventually, we hope to have literally thousands. Did you want to?
I just got to ask, what's the tree do on Main Street?
Oh, the tree, yeah, boy, I'm almost embarrassed that the tree doesn't do anything when you tap it, except respond to the tap, and it really should. There's a park bench that comes in if we load enough buildings. I guess it's not there yet. But I can load in some more samples. We could see the park bench. Yeah.
So with thousands of shops, don't you need a bird's eye view?
Yeah, and we experimented with some kind of map, and we just weren't able to pull off something that we thought was good enough. But there's also hierarchy here. You can have shopping malls such that going into the shop has a corridor of doors, and eventually, people always ask this too. Well, why can't I step back to different cities and just have a level here? Here I'm downtown, but I could step back to a country where I see little cities I can go to, and it might be at some point necessary to introduce another level of hierarchy there when there's enough types of services. But we think this will take us the next 5 years or so.
How about earthquakes and weather?
Yeah, well, we do have I don't know if you've noticed, but this cloud up on the street here is moving. It's moving behind the building, so that's a form of weather. Yeah.
Who does the zoning on Main Street? I mean, why should AT&T?
The end user ultimately does the zoning on their own Main Street. The end user is control of what buildings are there, and they will even enforce sort of vague standards that will emerge. We don't know yet about how big can buildings be. Will users find it obnoxious? We've already seen, as we've given this metaphor to the different developers, there was this escalation of building size. We expected. You notice we put the home here and we made it fairly modest. And then the AT&T comes and says, "Oh boy, our logo is on it. That's our corporate ego. It's got to be enormous." And I'll load in some other samples later, and you can see the buildings are kind of escalating. And I don't know exactly. I think the small screen limits it somewhat. And users convenience. People will reject buildings, and we have about 6 or 7 buildings that anyone can use built into the ROM, and then developers can also download their own.
Also, I assume the cloud is just for fun because since it moves, it has no productive value, right?
Yeah, it is just for fun. Actually, it was there. We call our network we're developing the cloud, and the initial thing we put there was it was a way of giving credits. When you tap there, you'd get the credits for the people who developed the telescript technology. I'll show you how we give the credits now, just because I mentioned it, which is instead we have a little commemorative plaque on the hallway with the General Magic logo when you get into it. Then this will demonstrate some of our sound capability. I haven't done that yet, where we list the people's names, different songs on different pages. I don't know if that was immodest or not. Actually, we put it on the ones from the licensed ones. I like showing this off, though. At the very end here, this befuddled face next to the legal boilerplate. And I'll show you more about where that face came from in just a second. Yeah.
Are there places that you can go where you can see the avatars of other people who've gone there so you can chat with them?
I think such a thing is possible, and I'll talk more about the telescript technology, which is the foundation for creating an avatar type thing. But it's possible with our technology. I think it's almost, can be said, it's in our future plans, but it's not exploited on day one. But I think point-to-point interactive communication, or not, it's not point-to-point, but just community of interaction is very compelling, and I'm sure others will be doing that as well as us. But yeah, one thing that is really interesting, maybe I'll just start talking about my next topic, just doing a little of this, is we've created this geography inside the computer, a sort of landscape. It's a very natural thing for creatures to inhabit the landscape that represent agents either serving yourself or representing others. And we have a strong set of animation classes that are the little creatures that can live in here. And I'll just get this little cat here, drop him down here, and he's a little pesky to, let's see, when I pick him up, he kind of scrunches up. If I drop him, he knows to tumble. And I'm going to just go back here, and I think he'll start running if I go back, and he'll run kind of beyond the horizon there, or he just stopped. I wanted him to run. Here, let me try that again. He's got a random element, so I don't know exactly how to get him to do what I want him to do. I'll try once more. No. Yeah. Yeah. Well, we also have. I'll show you the other nice little animal built in. Is of course, since we're General Magic, we have a bunny rabbit, and he does a nice little dance. And we can just leave these loose here, but eventually these are going to turn into the avatars. And it's a very natural follow, and once you build this kind of geography to populate it with programs that represent other people or tasks that you're just employing for yourself. Okay, the next thing I want to talk about is basic messaging, which is the very center of what we're doing. This is the key functionality, the reason that we created MagicApp. You create an electronic message by tapping on this message icon in the center of the desk. It picks a form of stationery, kind of pre-started message. And there's a way of setting your favorite kind. The default here is a little electronic postcard. Again, we're employing a tangible physical metaphor. Most of the people in this room are computer savvy and are probably electronic mail users. People who've never used a computer before think electronic mail is a contradiction in terms. They don't understand how mail can be electronic. When you present it to them as a familiar postcard, people say, oh, I know what a postcard for. It's for writing a small message. We cleverly arranged the addressing section to be a familiar 3-line address, even though the elements of it are not 3-line. But by, again, creating that familiarity makes people more comfortable with it. Obviously, you don't need a street address to send an electronic message, so we use to, from, and about. Now the main way of getting your content of the message in is, there's 2 main ways. For casual or personal type correspondence, you just dribble electronic ink with a stylus, and it's kind of awkward to do with the mouse here, but possible at least. And people just handwrite their notes, and I think now is a good time to talk about why MagicCap does not employ handwriting recognition. And there's a simple reason for that. Actually, Newton sort of educated everyone. I thought this would be a sticking point at all the advanced briefings, but we would say, well, we don't do handwriting recognition. Everyone's like, right, that's a good decision. Whereas just a few months before the Newton came out, we'd say the same thing. Everyone said, oh no, you have to support handwriting recognition. But in fact, we evaluated handwriting recognition from 6 different companies through the course of the project every 6 months. We give the people a very simple test. Bill Atkinson is great at doing this, which is he has a paragraph of text. He usually says, the number you have reached is not in service. If you require assistance, please call the operator. Something like about 90 words or so. And we asked the demonstrator to enter that text using their handwriting recognition system. And we never had one person who was able to do that. Without walking out full of excuses and embarrassment. And so it just doesn't practically work for users. Also, we're going after a type of user that doesn't understand how difficult a problem it is what it comes down to. If you appreciate how difficult it is, you can be very proud of it almost working. Usually it's pretty easy for the users to do the handwriting recognition, so if you just give them the current state-of-the-art in handwriting recognition, they'll think it's broken. They'll think, oh, this device isn't working as the designers intended it to. And so while MagicCap is full of open frameworks, and we expect some third parties to integrate handwriting right away, and maybe we will at a point in the future where we think it really pays off for the user. What we do is we have an extensible tool framework for allowing you lots of ways to work with content. This pencil here is down on the bottom because it's the currently selected tool. That tool was automatically selected by this postcard. But I'll show you how I could select another tool. Again, we use animation to draw the user's attention to what's going on. And this pencil has a nice italic brush. And in fact, if you're an expert enough to know about our little expert key here, you can bring up a little thing here where you can change the properties of the brushes. They have different colors. And they're not just limited to drawing tools. Like another example is the shape here, where I can get that heart shape, and now I can just kind of stretch out hearts. And it's possible in the architecture to make all kinds of different tools. So we don't have to think of every tool. One hallmark of MagicCap, but really a hallmark of the coming generation of fully object-oriented systems, is the wall between applications fall away. The tools, I think, are a great example of that. The tools, if you add a tool here, it can be used anywhere in MagicCap, in the calendar, in the notebook. The object framework is the unifying principle, and the whole thing can be thought of as an ecology of different types of software, as opposed to these walled-off applications where each one is a world unto itself. But so anyway, I think what I'll do here is I'll again use one of our option keyters to erase the whole thing, because I wanted to show the other main way of getting content in, which is using this projected keyboard. And this is really hard to demonstrate without an actual device, because the key point in demonstrating is this usable by ordinary people? And there's only one way to find out, it's to test. As a matter of fact, that's the only way we can find out if any of our user interface is any good, is just putting victims in front of it and tape recording them to see exactly where they stumble. And every single time someone's user tested, we've made changes in the software. even though there's been hundreds of user tests, because it shows us the bump in the roads. You can't use user testing to design the software because the users never show you the right way to do it. They just show you it's not right yet, and so you try another idea. And eventually, and we graph how people have problems with the various points, and we've made progress, although we're by no means perfect. We'll be able to, I can tell you, just by the rate of change where we have to stop, is we did not really plateau so much, and I predict we'll be able to make it more usable next year than this year, and into the indefinite future, because it's a challenging task, and it's also very humbling to see your grand ideas about how someone's going to view something fall completely apart under the scrutiny of a real user struggling with it. Yeah.
I have a question about the postage stamp. Is that measured in AT&T dollars, or?
Yeah, well, I'll tell you, with the telescript technology, there is a way of measuring how much execution resources you're using. We use the postage stamp for something a little bit different, which is showing the means of conveyance. It's almost like an airmail type stamp versus another one. And I can load in some examples to show you here, but since I've addressed this to myself, it picks what it thinks your favorite way of sending it to an individual is, and then you can tap on the postage stamp to change that. And there's both what service are you sending it via, because even though AT&T is built in, we do expect other services to be available. And then there's also a secondary stamp that sometimes appears when there's a choice of means to the service. Like the AT&T service, if I have a device that has wireless capability, I could choose to send it over the wire line or wireless, and we use the postage stamp to select that. Yeah.
What about sending and receiving from internet mail?
Sure. I'll show you how that works. We do that really nicely. Of course, it has to go through some gateway, and some of your content might be lost. The digital ink, there is an emerging standard for that, but it's like a lot of platforms have promised to use it, but no one's really using it yet. To be vanilla, you have to, only text gets through the gateways, unfortunately. What I do want to show here is, a little bit about the keyboard, and what I usually do when I demo it on a real device is I type something pretty fast, and people see that it's possible to type fairly quickly without making mistakes. The key thing about designing this keyboard as we tested it was users' happiness correlated with one thing more than anything else, which is how big can you make it. And we made it as big as we could here, but still keeping enough of the document under it to not feel lost. Our current user tests show that people like using this projected keyboard about as much as the best chiclet keyboards on organizers. We use, in our testing, the Sharp 9600 organizer, which is a $350 organizer. And people both like using it and can type about as fast as on a keyboard like that. They can't do nearly as well as a full-size keyboard, and we support full-size keyboards, including a standard IBM PC keyboard that you can buy at Fry's for $25. Can be plugged in right into the device.
What's the physical size of the device?
It's a little bit smaller than you see here. It's got I'm sorry. You see this screen image here is at 72 dpi. We have the same number of dots, but it's 100, so it's about 3/4 the size of this image here. Oh, okay. I'm sorry. Yeah. Everyone's screen is a different size, so I'm sorry. But it's I don't know the exact inches. Roughly 3x5, a little bigger than 3x5, 4x6, I guess. But the other thing is, and this took a lot of time for us to get used to at General Magic, was we came from Apple where we were making products. At General Magic, we're making technologies that others are using to make products, and the different licensees' devices are all different sizes depending on what they put into it. They're really ultimately in charge of that. Yeah.
Will this interface appear on the Newton, or have I wasted my money?
Well, that's really up to Apple. We would love, and we have tried many times to get them to license Magic Cap. As you know, we came from Apple, and we expected them to embrace our work, but they decided to steer the Newton. At the time we left Apple, Newton was something much different than it was, and Newton ended up getting steered right into our face, and they consider us an enemy. And so
because I was told that there were meetings between Magic Cap and Kaleida and the Newton.
No, okay. I'm sorry. I expressed that wrong, because at the level of Telescript, they're very interested in Telescript. They have a license to it. They have an intention to deploy it. That's great. I think they just hate Magic Cap. They don't hate General Magic. And of course, we could make it available on a ROM card for the Newton. And if Newtons were a smash success and it was a great way of reaching lots of people, we would, on our initiative, port it to the Newton.
Would it fit the portrait mode small screen?
Yeah, it's hard to imagine doing Magic Cap portrait mode. There were a lot of, that's a very key decision we made, and there were a lot of factors there. We envisioned from the very beginning, we didn't consider us making just small handheld consumer electronics devices. We wanted to make a user interface for all kinds of consumer electronics that included television sets. And of course, television sets have a landscape orientation. That was one factor. Doing this projected keyboard, believe it or not, was a main driver toward going to the landscape orientation. It's hard to see how you could do a usable keyboard in the portrait orientation. I wanted to show just a little bit. I'm going to run out of time without, but yeah, I'll go on with
Just do it landscape on the Newton. The user can hold it sideways.
Yeah, except the industrial design is awkward in that way. It wasn't. I think it's possible, but it's well. First off, they have silk-screened icons on it that would be perpendicular. The text would not be in the right way to read them, and some other things. It certainly wouldn't be ideal. But of course, if Apple's a big company, if they committed to this, they could make a Newton that in a horizontal form factor that could run Magic Cap. Yeah.
Are you going to be talking about TeleScript and the TeleScript environment and that language?
Yeah, if I have time. Let me just go through a couple things really fast here. One is I wanted to show this one special key on the keyboard we call the expand key. We want to minimize typing. And so we put in a little feature here, like if I type SF and say expand, it knows to expand that into San Francisco. If I say expand again, it just goes back to SF and can cycle through choices. The best way of seeing how that works is I'll just do it with S, which is not something a normal user would do because you'd get too many choices. But you get the names of cities, other users, and eventually it'll go back to S. We had this feature in the software over 2 years ago, this concept of macro expansion, and we took it out after user testing because people couldn't figure out how to configure it. It wasn't worth the complexity of having an extra key on the keyboard because people couldn't figure out how to use it enough. We put it back in about 8 months ago when we realized it could be self-configuring. All the information that you're typing into other places of the software are the exact phrases that you're using a lot. The names of cities, the names of people, the types of appointments you have. And so those are automatically available for expansion. That made it worth the effort, and we do have a way of entering your own expansions just directly as well. And I'll show you even how you can use a similar technique like this, but even more effectively if you limit the context of what you're asking for. The expansions can be automatic, and I'll show that shortly. Yeah?
Is there a data store or database underlying the operating system? And if there is there an import-export mechanism? And can you also mention...
Yeah, okay. I'm not talking too much about the system today, but Magic Cap is based on a very innovative object-oriented system where the object framework is really sort of the database. There's a ubiquitous object framework at the very lowest level of the software that's independent of any programming language. So I think this is a fairly common trend now, but at the time we started, object frameworks were generally considered to be bound to a programming language. And Magic Cap puts the object framework at a much lower level than most systems do, where even kernel classes are extensible by subclassing, and the memory management, there are only objects. There's no form of memory management beneath that. So an object can even get a message sent to it every time it moves its address, for example.
Can you include images in the postcards?
Great question, because this is just what I wanted to demo. So it's perfect. We want it to be a thrill to send and receive these messages. We want someone's heart to beat faster and a big smile on their face when they receive these things. The best way to do that is to engage the user with graphics and sound. And of course, as you see with these tools, I can draw anything I want, but I think most people have about as much artistic talent as I do, which you can, not draw something that you'd be proud to send to someone, no matter how long you tried. So for that reason, we built in literally hundreds of graphic images designed by an excellent graphic artist. Our main artist at General Magic is Susan Kerr, who I've worked with my whole career. And we make it really easy using this rubber stamp metaphor to just select an image and drop it on a card. So in just one motion, I can tap the stamper, go through different banks of stamps, and this is extensible. Not only are there multiple drawers, but there's multiple banks of drawers. I think this is an interesting ones to point out here, which is once we had this idea of stamps, we wanted to come up with stamps to express certain emotions in certain circumstances. Which stamp would you put on a card to express frustration? Which one to express anger or happiness? We ended up using these faces, which I think are is just one set of things. People tell us we're going to get in trouble for putting in a devil. Some religious fanatic is going to think we're a demon or something. But we went and did it anyway. What's interesting about the faces here is in internet culture, there's these things called smileys, which are little faces built out of parentheses and colons. And these are really just smileys in the era of bitmap displays. But so anyway, a little bit more on the stamps here. One thing you can see is the stamps are not necessarily static. They can move. That one's everyone's favorite because this is a common situation in life. In fact, it's the situation that I've been in the last 3 years, I feel. One step ahead you can stay, but never too much more. And we actually built in a whole series of animations, and animations can have soundtracks associated with them. I'll drop this birthday candle, and he plays a birthday song just by his presence. We actually, again, just like the Main Street phrase is copyrighted, the Happy Birthday tune is copyrighted, and you can't just use that without paying an exorbitant royalty. We came up with this solution. One of our contractors, who's a talented musician, combined enough notes that it's legal from the standard Happy Birthday song and the Beatles' Happy Birthday song into a unique melody. And so, hopefully we won't get sued by the Beatles or the Happy Birthday lady. And so it can shut up by that. I want to show you a little bit more about the sounds, because I think the sounds are also very compelling. What I like about the sounds is they have what I call a very high emotion per bit, in the sense that they're very small to send and express because they're just MIDI note files. And we have an 8-voice synthesizer to interpret those MIDI note files. So let me just play a few of them here so you get the feeling that they're not computer beeps, they sound like more or less like music. That's a good one for getting applause. And just to show some others, people always ask, well, here, I like this one, Love Me Tender. But you can set these so that you can drop them on a card and they will automatically play when the card opens. Excuse me? Love Me Tender is Elvis Presley wrote the lyrics, but it's an old folk song in the public domain. So we're allowed. This is the shipping software essentially. So, okay, now, but there's another very, very important point to make about the rubber stamps. And you notice just dropping on even a few stamps, and maybe we should look at just some of the other types built into here, so you get a feeling for them. But even dropping one or two on changes the character of the message. But the real beauty behind them is they're actually a framework for adding arbitrary attributes to objects. So let me just make this point and I'll do the question, which is the rubber stamps can have scripts in them that make them intelligent. So like this urgent stamp here, its very looks tell me, the sender, and the recipient that the card is to be treated urgent. But it's got a little bit of script inside it that marks the card as urgent to the mail infrastructure. So now your intelligent mailbox out in the cloud can say, oh, if this card is urgent and it's from Andy, I better fire off his pager or whatever. It's an arbitrary way of adding attributes to things. And just to show you other examples of that, like here's a confidential one that might imbue the card with, tell the communication infrastructure to encrypt it more or file it in a more secure place. Another example, I was talking before about how out-of-memory situations are one of the hardest ease-of-use problems because users never know about them until they get themselves in horrible trouble. They're in panic. We have automatic purging built into Magic App, where the device itself, when it runs low on memory or according to other criteria, will suggest to you things to throw out. We put in the save stamp because part of the criteria is if it has a save stamp on it, don't throw it out. Okay, question? Yeah.
Can you mail buildings to people?
Yes, and I'll show you an example of that. In fact, that's the main way buildings get on your. What we do is we have this concept called a software package, represented by a box in the storeroom. You can mail those to people, and in that software package can be buildings, doorways, rooms, literally anything you see in Magic App. And that's the main way new buildings get out on the street. Is you'll get a solicitation from someone. I have a new service. Do you want to subscribe? Are you interested in pursuing a relationship with it? You type yes, buildings on the street. Yeah.
I don't want to mail buildings to people. I want to mail things to buildings. Do I drop a postcard on a building, which would be reduce the step of having to address it, or do I slavishly follow the physical metaphor and drop it on a mailbox and have to address it?
Well, yeah, usually when you send, you don't even drop it. There's just a send button here, and it does the dropping for you. I'll show you that. When I say send here, it kind of leaps up into the outbox, and then the communication infrastructure takes over. It all happens in the background because we're fully asynchronous. I didn't even have time there. But yeah, and again, you see it was filed in the file cabinet. The animation really shows you that. We weren't doing that, and people were saying, well, didn't know the cards were being filed for them. Just by putting that little animation in there, it's much more clear that it is being filed for you. I want to show another use of rubber stamps, and I'll do that in the context of address cards. Yeah?
Quickly, is that copy or is that a link when you just stored it?
It was a copy. The real one, it's kind of got sent out into the network in a copy. But well, here I may as well just show you that it's distinguished from the real one because that's important. It probably filed it in a place called, and I'll show you a little bit about the automatic filing criteria, but if I just open this one that got filed here, you'll see it's the one I sent, but this big sent stamp got dropped on it. And now once I've sent it also, if I go to try to change it, it's going to say, warn me, you don't want to change it because it would get out of sync with what the user received.
The reason I'm saying that is that in a lot of environments, the most common problem is you have links to documents that change. And when you send them, you meant to send the actual document, not the change version that's accessed later.
Yes. Yeah, so that's exactly why we do copy it at the time, because otherwise you would run into that problem. When you send it, it's a snapshot of how it is at that moment. You could continue to change it.
And the reverse is most often required in case of database access. You meant to send the latest version of the database, not the actual committed record, not the version that was saved at the time of transmission.
Yeah, we don't have a way of sending live objects, in other words, a way of sending something and then changing it further and having that automatically be updated, although it's possible to build such a framework. I wanted to show a little bit more about rubber stamps and just how they can act as database attribute tags for expressing overlapping categories. Let me make a new address card here for a group. I'll make a group called my Christmas list. I could use the keyword here, but I like showing that this is usable. Notice it's smart. It was smart enough to capitalize. It's smart enough to automatically shift into numbers when you want. But I wanted to show here how a rubber stamp can be associated with a card. We have some just for purposes like that. So I'll go into occasions, get this Christmas tree, and drop a Christmas tree to be the characteristic image of this group. Then I can go to anyone else's address card. I'll go to mine here, and then using an expert feature, it'll bring it up to the same place I left it. But just by dropping this Christmas tree on the card, I'm automatically in the Christmas list now. And so the rubber stamps are a great way, and we provide a whole set of them to express the interests of people, such as like this collection of sports and various different types of hobbies. You'll drop a little camera on your address card, and that'll express to anyone you communicate with that you're interested in photography. You can also search on these images. I'll show searching in a little bit. I wanted to show a little bit just about entering addresses, maybe because I think there's some clever stuff there that's worth looking at. I'll add an address to this card. Usually when you enter cards, they come up with a template, but I'll add a new work address. And we have, again, an extensible framework. You can hold as many addresses as you like. Job title here, if I type in V, it was able to guess Vice President. That's something similar to that expand feature I was showing you, but when you restrict the context to just job titles, it's safe to automatically guess, and users love this feature. And it's not just built-in strings, but any string you type into there will be available for expansion later. And even better than that, fill in the company name here. It did guess General Magic from just the G, but better than that, it was able to guess the whole company address, because anytime it sees the name of a company, it says, oh, do I have that company already in there? I won't make the user type it. The addressing framework is extremely extensible, and I think the best way to show that is this collection of email stamps, where we create addresses for all the common ways of communicating with existing services. We're trying to create this new paradigm with Telescript, but we also have to work gracefully with the world as it is today. Someone asked about the internet. There's an interesting story about this internet stamp, which is since we needed a bitmap for each one, we had to create our own logo for the internet because the internet doesn't have a logo, and we're happy to put it in the public domain, or if someone owned the internet, we'd give the rights to them if they want to use it. But let's see how I'd capture an internet address, say, or I'll choose to use internet, and so I might be, you know, Andy, you know, at, let's see, I have to know how to find the @ sign, is you know, at magic.com or whatever. But you don't need to know, the internet one isn't the best example because the internet addresses are somewhat complex. It knows how to parse it for the @ there. But for these ones that are more public services, like let me pick CompuServe, I'll pick SkyTel here, is all that I need to enter. I don't need to know the internet address of SkyTel. I just need to know the person's account number, and the stamp abstracts away all the other information it needs. And of course, they're very malleable. We're very drag and drop. I can pull these off, move them to other people's cards, et cetera, et cetera. And it can literally capture dozens of different addresses for a person. The reason we do that is addressing is fundamental to communication. Okay, I'm running out of time, so let me go through a few things just fairly quickly. Show a little bit about the appointment calendar. We use a structured approach for new appointments, although we also do it unstructured. We have templates for appointments to make it easy for someone. You don't have to fill each one out from scratch, and third parties can install new templates. I want to just use a general meeting here, though, because I just want to show off one particular thing. I'll set a time for it. It's just complained. Oh, don't worry. That's just, this is my current version as of today debugging, and we've been putting in more and more checks to find aberrations, and that yeah, we pre-load addresses like jail and stuff, but if you don't if you don't like that, just get rid of it. I'll say school here because we're at school today, and once you select a person, again, you pick from lists. You don't have to type. An invite button appears, and I think this is something that you'll see more and more of in our software as it evolves, where the software itself can write messages from a certain context. So the date book can create this card to be sent off to a recipient, and it's got smart buttons on it, such that when the recipient taps on the yes button, it can automatically book it in their appointment calendar. We've set this up with Telescript so it can even be cross-platform. It's at least potentially possible to send a card like this to someone not using Magic App, like the Newton, if they embrace Telescript. And then you can see the appointment here. I just wanted to show that. I saw Kevin, who's one of the people I work with at General Magic's, in the audience, and I couldn't live with myself if I didn't demonstrate one of his inventions, which is how our global searching works. And like most object-oriented platforms, the walls between applications fall down. You no longer have to know where to search for it. I can search for a string. It'll find it anywhere in Magic App. We have a rather fanciful way that Kevin invented for showing you where it's searching. So if I say, here I'll look for some text, I can also look for graphics. But I'll say, find the word welcome, no matter where it is in Magic App. And it commissions kind of Sniffy the Wonder Dog to go off and say, is it in the Rolodex? Is it in the date book? Oh, he found one. There it is, welcome. And then keep looking. Any more? Look in the phone log, look in the notebook. Nah, he's done. Okay. I want to show a little bit about rules. We talked to them before. Most of what I've shown in Magic App to this point has been it responding to the explicit request of the user. The user's initiating actions. That's good because it's simple. It's very important to keep the software predictable. But often you'd like to set up policies so the system can take automatic action when a certain condition arises without having you explicitly drive it. So we have a framework called rules that we built into any place in Magic App. Can have a series of rules associated with it. I'll open the rules associated here with the inbox because I think they're interesting ones. And actually, since our January 6th demo, we've even improved this a little bit by showing you the parts of the rule that changes by underlining them instead of doing something no one understood before that. And so the rules, like let's look at this rule here. When a message from a certain individual arrives, in this case General Magic, play a certain sound. The simplest way to use rules is you can just enable them and disable them, and we build in enough useful ones, so some users will be happy with just that level. But the real power is when you customize them. I open it for editing, notice that it displays to the user in plain English. That's the best way for the user to understand it, but it would be a disaster if you had to edit it by changing the English, because English is much too subtle for the computer to understand. Although, you know, we'll eventually be able to do that. Now, we couldn't have pulled that off today. And so instead, you have simple ways of manipulating what you can change. I'm changing the sound here. This is our choice box object we use a lot in MagicCap, so you can even bring up a menu so you don't have to step through them. Or if I assign a person, I can even assign a group to this. So now the rule will read, when a message from a member of family arrives, play the too bad sound. Now my family isn't that bad. I didn't mean to do that. Here, I'll play the cheer in case my mom's watching. Or good night or whatever. And so I could even make a copy of that, so the previous rule would be there, or just accept changes to this rule. And the rules can be very powerful. Like, for example, this one here can do a full text search of a message. If the message contains this string anywhere in it, take a certain action on it. And so, but the most important point about the rules is that they're an extensible framework. We didn't have to think of every rule to be built into every place of MagicCap. The third-party developers can have their ideas, and it's very simple to add a new type of rule. And as I mentioned before, while the rules are nice in the context of the device, they're essential for programming your smart mailbox out in the cloud, where there is no user to drive interaction. Yeah?
How do you keep people from writing buggy rules?
Well, the same way you keep them from writing buggy software. Rules are just software, and so what you do is you give them strong base classes to inherit from that do most of the work. They're just subclassing the rules that are built into MagicCap that have been tested as good as we know how to test them, and so they don't have to know all that much to create their new level of functionality. But of course, there's no way to prevent people from writing buggy programming. The only way there is no way. But the way to minimize the number of bugs is to just test it as much as you possibly can in every possible circumstance. But we have, but the object orientation is a huge help at sort of partitioning the complexity and writing better software than you could otherwise. Yeah.
By way of encouraging you to say something about TeleScript
Yes.
anyway, what's the connection between these rules and TeleScript?
Well, okay. What happens is and I'm not registered with the service, so you can't really happen. But what when I change a rule out in the cloud mailbox, an agent will be launched out into the cloud to carry these rules to the intelligent mailbox. And the rules themselves are little TeleScript programs, and there's a framework for the mailbox to invoke the rule, to ask it whether or not it's time to trigger, and then also say, okay, now perform your action. So essentially the rules are sort of transliterated into TeleScript. There's also a courier agent that knows how to carry that up to the cloud. Let me talk a little bit about TeleScript now, and I could even I think the biggest confusion with TeleScript now is this term agent really has two different meanings. The way we use agent is very different than like Patty Mays, who I probably didn't say her name right, but I saw she was talking at this class last week. There's kind of user interface agents that are often anthropomorphic or look like some creature, and they do things inside your device, and that's a great area for exploration, and it's relevant to MagicCap, but that's not what we mean by a TeleScript agent. A TeleScript agent is a piece of software that you send out into the network, and it's called an agent because it interacts on your behalf out in the network. The key insight of TeleScript is there's a couple different ways to talk about it. I think my favorite way of talking about it is that the communication services have been very slow to evolve compared with desktop PCs, because it's very difficult to iterate and modify. We can make MagicCap by just trying out ideas one after another, see what works on users. You can't really do that with a communication service because it's not an open platform. Communication services can't trust just anyone to develop programs for their servers. And it's been very difficult to build a communicating application that has a server component and a client component because there isn't this open server platform. The key insight of TeleScript is that, well, what if the only software you have to install out in the network, besides basic low-level communication stuff, is a language interpreter? You don't try to have the service dictate any features other than I am capable of executing this interpreted language. Then all the features can be built out of just data sent up to the network. The network becomes extremely customizable. So what TeleScript is an interpreted, very high-level, object-oriented programming language designed for these communicating applications.
And what protection is there against a virus?
Okay, okay, that is the key. And you know, I don't know if people saw the day AT&T announced personal X service, January 6th. John Markov in the New York Times wrote their headline was kind of virus, you know, spawning ground for viruses. And of course, as soon as you understand the concept of TeleScript, you make that connection with viruses, because TeleScript programs are programs that willfully travel from machine to machine. But the art of designing TeleScript is to design it in such a way that maximizes the benefit you can get and minimizes the risk. In other words, TeleScript, the concept of sending a program out on the network is, while it's a breakthrough concept, many people can have that idea and not be able to build anything practical out of it because of the security concerns. We'll have done an excellent job at designing TeleScript if we solve that problem well. That is the key focus of the design of TeleScript. So the way we address that is a number of different ways. One very important thing is it's important for the language to be interpreted as opposed to compiled, because you build a virtual machine that the agent can't reach behind. There's no way it can talk to the file system. There's no way it can poke into memory. It just can't, because it's not in its vocabulary of what it can express. Yeah.
Can an agent create another agent?
Yes. Okay.
How do you prevent a million agents being created?
Because fundamental to TeleScript is this notion of permits and constraints. An agent kind of has a budget of how much resources it can spend, how much clock time it can live for, and restrictions. And it's always engaged in a dialogue with a place. I should talk a little bit about the basic abstractions of TeleScript in the network are something called a place, which is a venue in the network that has something to offer to the rest of the network. Agents are little programs that travel between places. The most interesting instruction in TeleScript is this instruction called go, where an agent executes go against another object called a ticket that specifies a place it wants to go to. And if that place accepts that agent, the next instruction, it could throw a fault for various communications reasons, but if it successfully executes the next instruction, that agent will be executing on some other computer, possibly running a completely different operating system with a different microprocessor thousands of miles away. So these agents can hop between different services in order to fulfill the requirements of whoever created them. And there's a whole series of the essential problem of the design of TeleScript is putting the right kinds of permits. There's also a concept of an authority. Every agent has an authority behind it, which is essentially the person who is authorizing the agent to operate. The authorities are unforgeable because we use RSA public key cryptography infrastructure. It's very difficult to forge an authority, so the agents always have to be who they say they are. And then the way the execution of the agents are constrained is the essence of what makes TeleScript a practical infrastructure. And of course we'll learn a lot by building it all out. And we've laid the foundation. We've built the first little applications, and we'll see where it goes. But that's the key design consideration of TeleScript is to limit the possibility of rogue agents. Yeah.
Is TeleScript exportable?
Excuse me?
Can you export it?
Yes. We checked out with all the RSA stuff by using it just for authentication in the mainstream use of TeleScript and not for full encryption. That makes the defense agency or whoever it is, the NSA, whoever it is making all these funny rules, more happy with it. And we worked at it and we got the approval to do that. And in fact are working with various international partners. Yeah?
You can, in an interpreted environment, you can protect from the file system and what have you, and you can also do that in a compiled environment, but the agents are going to be able to interact with the Magic Cap world or the rest of your interpreted environment, and they can do just as much damage there, and the question is, what do you do about that?
Well, we have to build in some kind of protection to limit what the agents can do in Magic Cap. The agents are still just as constrained, but when they talk into the device, they make requests to places, TeleScript places in the device, and usually we rely on the authority. You have a concept of do you trust the authority behind the agent, and the simplest way is to just maintain a group of trusted people. Their agents can come into your machine and execute at will because you've said that you trust them. and then of course you could create telescript places that have arbitrary constraints on the agent. The agent has to know the secret password from last Tuesday before you let it do anything. A place can define that if it wants to. That's an open framework. We are not really strong at, because the devices are essentially personal and private, there's not an industrial strength framework for constraining the agents on the device like there is in the network. But it's certainly possible to create that, and as things evolve, we'll evolve the frameworks in Magic Hat.
So the basic, sort of once an agent is inside some place, they can do anything, and the security.
No, they can only do operations that the place permits. And that's a key point. They can execute any telescript primitive within themselves, so they can kind of compute prime numbers and something like that. But they can't kind of get out of into the environment unless that place permits them to. Places have a concept called a vocabulary, which are the operations the agent can execute against that place. And they can even restrict the vocabulary in certain circumstances. If the agent meets certain criteria, you can execute this operation. And it's really much too complicated to get into here, but that is the key design criteria for Telescript is making these mobile programs very useful without making them dangerous. And I don't know how well we succeeded. We'll find out. But that's the nut of the problem. I wanted to show, before we get into just questions, I wanted to show one little aspect of Magic Hat. I know we have to stop in 15 minutes, so let me have 5 more minutes of demoing. The rest will be questions, if that's okay, because I didn't get a chance to show you anything about the way Magic Cap is a construction set. Magic Cap is not just an end-user platform, but it's incredibly malleable and customizable by individuals. I want to show a little bit of that. In fact, we started out as much more of a construction set. Bill Atkinson, one of the main guys who worked on it, his previous project was HyperCard, and so we brought a lot of that heritage to it. We started out even more of a construction set as we are, and our user testing showed us, well, boy, people don't want to accidentally customize. So we ended up creating this little thin glass wall of having a user level here where when I flip this switch, the stamper turns into a magic hat to let me know I'm in construction mode. And suddenly things are more malleable. I can now change the position of almost any of these objects. When I open up the hat, instead of just having the stamps are still there, but they're just one category of components I can use to build with. And we use this metaphor called coupons to express properties. So probably the best way to show that is I'll get a shadow coupon here that represents a gray shadow, and as I drag it around, objects that can accept it light up. If I want to drop it on the clock here, the clock will now have a little shadow like that. Or in a similar fashion, when I tap on the phone here, it makes a little ping sound. Ping, I'm not sure everyone can hear that because we don't have the computer mic, but I can go into my building blocks here and get a little coupon that represents a phone ringing. Drop that on here, and from now on, whenever I tap on the phone, it'll sound like that. Now, the user might ask, where did that coupon go when I dropped it inside the object? It's disappeared. It's gone from the screen, but obviously it's still around. I can still hear it. It's still expressing itself. For that reason, we have another tool we call the Tinker tool, where you can open up an object to see the properties inside it. So if I tap on the phone here, it opens up, and I see an image property associated with it, or I can get this sound property and drop it, say, on a different object. And there's all sorts of such properties, like I can change the color, and so all of this is customization done without any kind of programming, just drag and drop to make users in control of their environment. There's also a set of tools that we call authoring tools, move, copy, and stretch, where I can take any object I see and make a copy of it. Like I'll just make a second clock, and I could stick it here, but what I'll do here is put it in my little satchel, go out to the hallway here. I don't know why it just made that ringing noise, but what I'll do, let's say I'm hanging out a lot in the center of the hallway here. Notice the bunny's still around. I'll get the move tool, and just when I move on the corridor, it moves kind of everything out of the way. The hallway itself is very malleable, and then I'll just take the clock here, and I've just customized my environment like that. So the point I wanted to make is it's very plastic, very malleable, and that's both for end users. The line between an author and a user is a very nebulous one, and we want to seduce people into becoming authors. because that's the real magic of this media called computing, is letting the user impose their will on the environment. And so we're big believers in that and invested a lot of our development time. The one last thing I'd like to show is the ultimate in customization isn't just changing sounds or other properties, but it's doing arbitrary semantics, creating applications. And we have an end-user scripting language built into MagicCap that's innovative and interesting to see. I'll just do a quick demonstration of that. What I'll do here is go into my components. I haven't shown those yet, but you know, there's like switches and dials and that type of thing. But I'll just get a button here. And what I'll do is I'll make it so that every time I press this button, it'll make the file cabinet appear or disappear, just as a simple example of scripting. I can get into the script editor by tinkering this button to say, show me what's inside you. If I hold the expert key down, that's one way of getting up the script editor. Tapping on the inkwell makes new statements. The way the scripting works is, especially because we had a keyboardless system, we had to be able to script just with tapping. So the scripts are sort of like smart forms. When I tap on this new statement, it gives me what type of statement it is. I'll choose an operation, which is our way of sending a message to an object. I'll connect this to the file cabinet object, and now it kind of guesses a script statement by the most common thing that you might ask a file cabinet to do. If you want it to be something else, you just tap there, and these are the choices. These are the things that the file cabinet can do. Most of them are inherited from the superclasses. This add sorted one is one native to the file cabinet, but I'll just choose this get set visible operation, and if I tap on get, it gives me the other alternative set. So I think in about 4 taps there, I created this little script. When it's time to do your thing, set the visibility of the file cabinet to the opposite. It guessed opposite. That's what I want. I just wanted to show you if I tap there, there's other alternatives. When I put it away, it's smart enough even to guess a good name for the button from the most prominent verb in the script. And when I execute it, it actually even works. And most of the buttons in MagicCap are connected up to their semantics through scripting. We don't use scripting to build the user interface framework and the lower levels of the system because it would just be too slow to execute acceptably. But we keep the higher level semantics that way because that makes it malleable for the end user. Okay, now, so I think I'll stop now. There's a lot more I could demo or talk about, but let's spend the rest of the time with questions.
Can you give some examples of what you would use Telescript for?
Yeah. I think the ultimate, built into MagicCap right away is using Telescript to create an intelligent mailbox and intelligent messages. So your mailbox out in the cloud can be programmed with arbitrary considerations. Anytime I receive a message from person A, forward it to person B, without you being there. You had to have Telescript for that because it's executing out in the network without anyone to drive it. Or another example is I could send a little program, which we call an agent, to, say, the Dow Jones computer or something like that, the Charles Schwab's computer somewhere that has a Telescript agent in it, and I'll say, write me a message every time Apple stock rises above 60 or dips below 30. And now that's very cheap compared to having to call up that stock service every 5 minutes or every day or whatever, because it's executing in the computer, whereas those stock prices are right in memory, no communication required. But when certain conditions are met, and the conditions can be arbitrary because Telescript is an arbitrary programming language, it can take action according to perform what I've asked it to. Eventually, where we see Telescript going is being infrastructure for a new kind of electronic marketplace, where I can send little programs out into the network that represent, I'm either a buyer or seller. I have something, or both. I have something I want to sell to people, or I have something I want to buy. This agent knows that and can meet with other agents and negotiate, find the best deals, put me in the loop when I program them to, if appropriate, or even empower the agents to actually complete the transactions just between the agents. And so it's very exciting. There are other application areas we haven't even explored yet, but we're hoping the third parties take us into. One great example is network management. You can do network, all kinds of network bookkeeping and diagnosing problems. You can have agents that are constantly traveling around the network, doing tests, performance measurements, rerouting, etc. It's really not just for mail, but for distributed applications. And I'm sure the most interesting applications are ones that no one has thought of to this point.
Yeah, the Schwab example makes me ask about the execution model. Because if you did the easy thing to do what you said, there'd be 10,000 agents sitting in their computer on wait loops.
That's right, but the agents are pretty light. I mean, a basic agent like that could be as small as 100 bytes or so. So it's it's like not so much bigger than a message, and they do block. So there is a reasonably sophisticated scheduler. So they're not polling. They can block on certain, ask to be notified when a certain thing happens, or and I get the other answer too. I think is cycles are pretty cheap these days and are getting cheaper and cheaper. Memory is probably more of a concern, and then of course the communications bandwidth is relatively expensive compared to the thing. But I'm not sure exactly what you meant by execution model. It's interpreted, and so things run concurrently, and they're interleaved at the instruction level. Yeah.
How do you deal with money and computational resource management and that kind of thing?
We don't have a concept of digital cash or actual spending money built into TeleScript itself, at least at this time, but we do have a very rigorous notion of authority. So every agent is who's responsible for it. There could be, at least conceptually, a credit card associated with the agent that is unforgeable. And so at least initially, we'll use credit card infrastructure to do the transactions. Eventually, some form of digital cash will emerge.
So how do you deal with computational resources? The compute time that an agent gets to spend and the memory.
There's a concept in the TeleScript interpreter called a teleclick, which is really just a TeleScript instruction or set of instructions executed. The engine keeps track of that. One of the constraints on permits are you send an agent into the network and say, oh, you don't have more than 1,000 teleclicks, which means you can't spend more than $3 no matter what. You commit suicide if you get there. And the frameworks are worked out to the point where there's a little extra resources you have. Instead of committing suicide, it gets very, very restricted what it can execute. But it does have a little safety hatch to at least send you back a message saying, I ran out of money, like a college student calling their parent. Yeah?
Is a TeleScript syntax in the public domain?
Yeah, there's actually more than one syntax. No, we haven't put anything in the public domain, but it's open. It's open, and we have applied for a patent on a couple fundamental concepts. The patent hasn't granted. Our concept is because we don't want it to turn into Babel. We don't want competing implementations to be incompatible with each other. We want to license for a very small fee, although it's yet to be determined because we haven't found anyone who is following this business relationship yet, but some kind of architecture license that gives us a little bit of control over the architecture, have their engine conform to some kind of compatibility testing, and they'd get the rights to implement the language completely themselves. We have committed to documenting every interface to make it possible for others to write their own TeleScript interpreters. That's necessary for it to be accepted as a ubiquitous standard. And we haven't done that at this time. We plan to around the end of the year, although the date isn't set, when the full set of specifications will be published. Yeah?
When will the first finished products come to market?
I think this summer could be as early as, say, late May or June. Could be as late as August or September. You'll see devices from both Sony and Motorola on sale. The AT&T service called Personal Link will kind of open its doors for full business, accepting any customer. The current schedule, I think, is July for that. So right about the time the devices appear, we hope. Yeah. Yeah, we use Macintosh MPW and the C compiler there. We've created, as part of MagicApp, an object framework that is independent of any programming language. So it's all built in this object-oriented framework that isn't part of the language. And you really have to, we can work with any programming language because the way you send an operation to an object is just using a procedure call. So to send like the draw operation to some viewable object, you just say draw paren, just a C function called draw. And the first parameter would be the object that's receiving it. And instead of just doing a JSR there, it traps to our runtime. That's part of MagicApp, where the inheritance hierarchy is traversed, and there's all kinds of caching to make it go fast. But that's essentially what we do. But we're not limited to C. We have some percentage in assembly in MagicApp itself, and other developers can use virtually any programming language that has the concept of a structure and a procedure call. Yeah.
How hard would it be to establish a publishing situation within it where you could have something resembling the normal intellectual property protections and collect royalties?
Well, that's our hope, and we have some companies are attempting things like that. The infrastructure is great for that, and I think you'll see it arise in fits and starts as issues come to light from people actually doing things. What our job at General Magic is to make the toolkits that remove the technology barrier from someone with information, to make it as easy, using these tangible metaphors, to get your information in, upload them to the cloud, configure whatever policies you want for distributing it. You could even have barter as well as cash. I'll give you your information if you give me yours, and the frameworks will evolve. We believe in a wild and woolly, open type situation where there will be problems from practical implementations. We'll learn about them and deal with them as they arise. Yeah, Mark?
Can agents do distributed transactions? Can I send out an agent to find me the cheapest 4 meg by 9 sims at any of the vendors?
Yes.
But only buy exactly the amount that I need?
Yes. Now there's a couple frameworks that you need for that. One is some kind of directory framework. We call it Yellow Pages, where people can be listed according to certain criteria. Ultimately, what you get down to is what I call the taxonomy of information problem. It's very easy for an agent that was written by the creator of the place it's going to know everything about that place. And I think that's what you'll see initially, more or less. Eventually, you'd like to be able to have arbitrary agents that were not written with any knowledge of the places that they're visiting, be able to go to those places, find out what they have to offer, and make decisions based on what they're. And so for that, you need some